continue our discussion on reflections. So yesterday we talked a little bit about this. You guys did a little bit of homework. Let's kind of get a little visual on putting it all together. So this says we have a reflection over the x-axis. So let me go ahead and draw a line across for the x-axis right here. If I'm reflecting over the x-axis with this line here, my pre-image is AB. So my new image would be what? Let's look at it. So it would be, so this one says -3, 1. What's this one say? -3, -1. What's the only thing that changed? The y. When we're going over the x stays the same, the y changes, right? Because actually we're talking about elevation. You're only moving up and down on the y-axis. You're not moving on the x. Let's talk about the y-axis. If we're reflecting over the y-axis, is y changing?
No.
Y isn't changing. We're not moving across the x, we're moving across the y. Did we change any elevation from going from point A to point A? Elevation didn't change. Horizontally it changed, right? What value is horizontal, x or y? Horizontal, x. I'm still a big fan of doing it graphically. I think that's the best way to see it, the best way to understand it. But when they're talking to you about rules, I want you to know what they're talking about. I want you to know why A changes and B doesn't change, right? Okay, what about this one? Let's skip the origin. Let's go to y equals x. Y equals x is this line right here. Correct? And we talked about yesterday that if y equals x, couldn't they change places and still be the same thing? Isn't y equals x the same thing as x equals y? Correct. So what would this coordinate be? BA. They switched. Now this is the only one that really trips me up. This is a straight line, right? So only one thing switches. This is a straight line. So only one thing is changing, right? This is not a straight line, it's a slanted line. So these just switch places. This is more of a rotation. So what would this one be? Good job. Negative A, negative B. They're both opposites. Kind of like if you take the negative one and then you take the negative the other, then you're still in the same spot, right? So that would make sense why both of them have to be negative, because if they're both negative, then you haven't made a change at all. That's the way I remember it. If I start at 0, because if we're reflecting around the origin, aren't we just reflecting around just a point? And reflecting is going around, right? What do I have to do to find these coordinates? What did I physically do? I know that B changed. How did it change? It has a negative. How do I apply that? How do I make something negative? Multiply it by a -1. So I multiply y by -1. What am I going to do with this one? Multiply x coordinate by -1. What am I going to do with this one? Multiply them both by -1. What am I going to do with this one? Interchange the x and y coordinates. That's just kind of like a cheat sheet for you. All right, so the final thing we have to look at in this section is this. If a figure can be folded so that two halves match exactly, the fold is called what? A line of symmetry. A line of symmetry is different than a line of reflection. How? Is this F right here, this figure, is this symmetric?
No, because
Fold it, it wouldn't work. But could I reflect it? Absolutely. It could be reflected, right? I could actually take a picture of it and reflect it. It can be reflected, but you cannot cut it in half and have the other side exactly like that side. Correct? What about this one?
yeah, because you fold it.
When you fold it, it's going to have symmetry, correct? What about this one?
Yes.
What about this one? Yes. Okay, let's talk about something else. For some figures, a point can be found that is common, that is a common point of reflection called a point of symmetry. That's funny.
Well, it sounds like we're not.
So, a point of symmetry is where no matter where you go on the other side, it will be even or congruent. So let's go right here. Point of symmetry would be right here. If I try and draw a line from here to here, if I go in the opposite direction, is it going to be congruent?
Yes.
What about here?
Yeah. Yeah.
What about here? Right? See that? And this one's obvious. What about this one?
Well, you don't have point. You don't have point. So you don't.
So does it? Does it have a point of symmetry?
No, it doesn't have point.
It doesn't have a point of symmetry. If I made a point right here, would that be symmetrical?
No.
If we go here, if we go directly across, is that going to be even? No. See what I mean? Does this one? No. These do. These don't. Anybody have another example? Not really, though. Is your face symmetrical? Haven't you ever seen one of those where they actually like cut it in half and you can see how your face is not symmetrical? That's supposed to be a sign of attractiveness, is the more symmetrical somebody's face is. But that's neither here nor there. Okay, so this is the only one we have to look at still. Determine how many lines of symmetry a regular pentagon has. Then determine whether a regular pentagon has a point of symmetry. So let's take, can I cut this in half? All right, let's cut it in half. About right there. So, is it symmetrical?
Yeah.
Is that the only line of symmetry?
No. You can't.
If I were to cut it like that, is that symmetrical?
No.
Really?
I think so.
What do you mean if you were? I can. Is it symmetrical? Right? So what do you think is going to happen if I keep turning it? How many is it going to have? 5. Good job, guys. It will have 5 lines of symmetry. Does it have a point of symmetry?
Yes.
Really? So from here, anywhere out, it will be the same? Let's look. I'm going to rotate it. Now this is why I'm a big proponent for doing a lot of exercises on the computer, because you can take these things and manipulate them and discover things for yourself, right? So if I were to take this and spin it, would it be, oh, it's not going to let me have a fixed point. See, if it was awesome, it'd let me have a fixed point. Can I take this and, you know what I could spin? I could spin this right here.
Oh, yeah. It doesn't matter.
Yeah, it does.
Yeah, it does.
Does it have a point of symmetry?
No.
What do you mean you hate it? Don't you understand what I just did now?
I understand technology is taking over the world.
Right? That shows you how it doesn't have a point of symmetry, right? Because it should be symmetrical no matter how I turn this right here.
Yeah, it is.
See that? There are places that it'll be symmetrical, but is it symmetrical all the way around?
Not exactly.
No, it's not. Okay, we're done.